So the first one on the second one says find the domain. So if you remember, domain are x values. So this one, we go from negative infinity to 4. And then there's a little break. And then let's see, there's a hole there. So we could say from 4 to infinity. And then we can say x cannot equal at our hole of 5. So there's a variety of ways you can write that. So where is there a 0? Well, there's a 0 at x equals 3. What is our end behavior? So the limit of f of x as x goes to negative infinity. And then we have the limit of f of x as x goes to positive infinity. So as we go to negative infinity, where does it level off? Well, it's leveling off at 1. And on the other side, as it gets bigger, it's also leveling off at 1. So limit notation of the vertical asymptote. So the limit of f of x as x goes to, it's 4 from the left-hand side, and the limit of f of x as x goes to 4 from the right-hand side. So on both sides, it's the y value is shooting up, so we would say it's going to positive infinity. And then our hole. So the limit of f of x as x goes to 5 from the left-hand side, and the limit of f of x as x goes to 5 from the right-hand side. Well, both sides, it doesn't matter where we're going to that height of 4. Okay, so we have quite a few questions to answer on the next one. So we know we have to factor it. So this one I know I can factor out an x. So x squared minus 2x minus 15. So this would factor into x minus 5, x plus 3. And our denominator would factor into x plus 3 and x minus 2. So I know this simplifies into x minus 5, and x minus 2. All right, so our domain. So again, it's all real numbers, but we know x cannot be negative 3, and x cannot be 2. All right, letter B, the 0. So in our numerator, so we'd have 2 zeros when x equals 0 and x equals 5. The y-intercept. So when x is 0, if we plug that in, let's see, 0 times 0 minus 5 over 0 minus 2. Well, that's 0, so it's that coordinate 0, 0. Are there any holes? Yes, at x equals negative 3. Let's see, if we plug that in, negative 3 times negative 3 minus 5 over negative 3 minus 2. Negative 3 times negative 8. So 24 over negative 5 is our y value. So negative 3 and negative 24 over 5. Horizontals. Well, if we look at our degree, the numerator is greater than the denominator, so there's a slant. So then we have to find it. So we have to do our division. So let's see. So we have x, oops, that goes on the outside. X squared plus x minus 6. And then on the inside, so this first term goes on the inside. So x cubed, so times x. Fill in what we know, so that's x squared negative 6x. So next are our x squareds. And it looks like we want negative 2x squareds, and we have 1. So what do we have to add to that 1 would be negative 3x squared. So this would be minus 3 up there. Multiply that out. So this is negative 3x, 18. And we could finish this if we wanted to. Again, you wouldn't have to. We need negative 15x. So we have negative 9x. So to make negative 15, negative 9 minus 6x. And then our numbers would have to be negative 18 because there isn't one. But again, as soon as this is that line, there's our slant. So y equals x minus 3. Oh, and I missed this last one, vertical. So what makes a 0 in our denominator would be x equals 2. All right, on the next page here, finding the limit as t goes to 3 from the negative side, from the left-hand side. So what happens as we go to 3? Well, it's getting bigger. So I would say infinity. What happens from the left side? It's getting smaller. So this is just words. As t approaches negative 3 from the left, d of t approaches infinity. And as it goes from the negative 3 from the right, it approaches negative infinity. So just in words there. So use that binomial term to expand. Okay, well, we need the 5th row. So that would be 1, and I would give you Pascal's triangle, guys. You don't have to memorize this. 10, 10, 5, 1, x, 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 and x. 3, 3, 3, 3, 3, 3, power 5, 4, 3, 2, 1, 0, 0, 1, 2, 3, 4, 5. So if we multiply this out, this is just 1x to the 5th. If we multiply our numbers, 5 times 3, so that gives us 15x to the 4th. Here we would have 10 times 3 squared, so 90x to the 3rd. What do we have here? 10 times 3 cubed, which is 27. So 270 x squared. Oops. So 5 times 3 to the 4th. So 5 times 81 is 405x. And then our last one is just 3 to the 5th, which is 243. So our final answer, 1x to the 5th, 15x to the 4th, 90x cubed, 270x squared, plus 405, plus 243. So now it says find the 5th row. Well, again, you don't have to memorize the triangle. You could go to that 7th row. So if I wrote down the 7th row, I'm sorry, I don't have it on here, so just look, and here's our 7th row. We need to find the 5th term, 1, 2, 3, 4, 5. So this is 2x and negative 1. And I don't have to fill this all in, because I could go, I know this is to the power of 7, 6, 5, 4, 3. And if it has to add to 7, this has to be 4. Otherwise, we could go 1 to the power of 2, 3, 4. So this is the term we want. Well, this is really 35 times 2 to the 3rd, x to the 3rd, and negative 1 to the 4th is just 1. So let's see, 35 times 8, so we have 280 x to the 3rd. Now we have a couple transformations. So minus 2, so to the right 2 and opposite y values. So to the right 2, boom, boom, opposite y would stay. This next one, to the right 2, opposite y would flip it down. This one, to the right 2, and we flip it down. To the right 2, and we flip it, so that would not change. That would stay there. So what is this next one? 2 times y, and then down 4. So our y value is negative 2, so times 2 is negative 4, and down 4. This one is a height of 3, so times 2 it's 6, and down 4. 1, 2, 3, 4. This one is another height of 3, so times 3 is 6, and down 4. And this one is a height of 1, times 3 is 3, and down 4 would make it negative 1. So again, it's on the inside, so x times half and up 5. So this is at negative 5, so half of x is negative 2.5, and then move it up 5. This x is at negative 1, half of it is half, and up 5. So that's going to go here. This is at x is 2, half of that is 1, up 5 is 8. And we have it right there. So what are these next transformations here? All right, so what are we doing on these transformations? So find g of x. Well, we take f of x and add 5. Okay, 6 minus 4x squared plus 5. So that would be 11 minus 4x squared. And there's our g of x. So find g of 5. And here's our table. So we know here's g of x. So g of 5, we plug in f is 5, or x is 5. So f of 5 plus 2. What is this f of 5? Well, f of 5 is negative 2. So 3 times negative 2 plus 2. Negative 6 plus 2 is negative 4. So what happens on this next one? Domain and range. So we have our domain and range. And then find the domain and range of g. Well, let's see. It moved to the left 3 and opposite y and down 2. So our domain is the left-right shift. So our domain moves to the left 3. So here was our first domain. To the left 3 would be negative 8 and 0. And our range. So our range is the opposite y value and down 2. So if we take negative 4, if we did the opposite, it would be 4 and negative 8. Down 2 would be 2 and negative 10. So if we list the smallest first, negative 10 to 2. All right, so is this data linear, quadratic, or cubic? So a couple ways. You could see, take a look here. Let's see, 18 to 28. So we have a couple going up. So let's see what, if we have an equal value of 10 over here, it goes up by 3. The next 10, let me re-highlight those. So we have to check our rate of change, we have to be going up by an equal amount. So 18 to 28, 38, and 48. So if we were to check that, each time x's are going up by 10, this y goes up by 3, 53, 63, 73, that goes up by 23, 75 to 105, that's going up by 30, so that's going up by 20 and 17. So it doesn't clearly look to be quadratic. We don't have enough to check cubic on this table. So if you graph this and make your scatter plot, you could see what it looked like. And I don't have a calculator on here, so I'm not going to graph it. So again, if you're unsure how to graph, make sure you take a look at the calculator help on Schoology there. Because I believe if you were to do a quadratic, if you thought this was quadratic by graphing it, your regression equation would be that, and then if you plug in 34 for x, 0.734, 34 squared minus 2.753 times 34 plus 73.845, you get approximately 65.1. So this next one is another calculator active one too. And again, I don't have the calculator on here, so I can't show you that. But we have somebody jumping off a cliff, and here is it's modeled by. So what is the restricted domain? So our restricted domain, we have to think about, well, when the time starts at 0. So it's 0, and then you can graph it. Where does it hit the ground again, right? So where does it hit the water? And on your calculator, it hits it at about 2.72. And what is the restricted range? From 0 to 83.06, because we want that height up here. All right, so a couple multiple choice ones here to end this. Or actually, there's a few more after that. But a couple multiple choice. The rational function is given by this, where k is a positive integer. If the function has a slant asymptote, what is the value of k? Well, to be a slant, the numerator has to be greater than the denominator, right? And by 1. So if we look here, here's 2 x's, and we know the bottom has 5, so our top, the total, would have to be 6. So for that to work, we would have to have 4. X to the 4th. Or k would be 4, because then we'd have our 4, 5, and 6. So what describes this end behavior? Well, we know that this is a rational function. And if I look at the degrees here, we know the bottom, 2, 3, is x to the 4th, and the top is the 5th. So we know it has a slant asymptote. So what happens as it runs along there? Well, as we move this way, it's going to go down. As we move where x is positive, it'll be going up. So as x increases out without bound, our f of x, g of x also increases. As it decreases with bound, it also increases. Well, that's saying they're both going to infinity. That's not the case. As it increases without bound, g of x increases, so it goes to infinity. As it decreases, g of x decreases. Well, that matches it, so it has to be that one. All right, number 16. We have a table here. So which best describes h of x? So it has a hole. Well, does it have a hole? Well, if we look at our values, it's going to a similar number, so it definitely has a hole. So it's not a vertical asymptote. The hole wouldn't be at 3 over 2. Well, actually, where is our hole going to? X equals 3 over 2. I agree, our y value is 1.5. But our hole is at x equals. And then 17 and 18. The function is defined by f of x over g of x. What is the value of r of x? R of 0. All right, so we know that r of 0 equals f of 0 over g of 0. Well, what is f of 0? Well, that is 3. G of 0 is also 3, so it would be equal to 1. And then the last one, the function is defined by f of x over g of x. What are all the vertical asymptotes of r of x? Well, let's see. What do we know f of x is? Well, what is this equation? Well, it's just a line. So y equals mx plus b. Let's see. It looks like our slope is 1x. Our y-intercept is 3. So that's x plus 3. Well, what do we know the bottom one? We know the bottom was a parabola, and it's got to have x plus 2 and x minus 3. Let me see here. I gotta erase this. So, what are all the vertical asymptotes? Well, there's no hole, so I would say it would be this one.